We continue with the presentation from Ryzen. We are really happy to have again with us Yifeng Song from Ryzen Energy. Those who joined our HJT event in the past will have already seen him speak there. Yifeng is the head of product management at Ryzen Energy, and he will talk about the benefits of two 10mm G12 solar modules along the value chain from wafers to systems. Yifeng, the floor is yours.
Okay, thank you, Michael, and all the audience here in the webinar. So everyone can hear my voice, right? Hello everyone. So this is Song Yifeng from PM department of Ryzen Energy. So thank you very much to join this TaiyangNews webinar. So my topic today is the benefits of Titan solar modules along the value chain from wafers to the PV system. So firstly, please allow me to give some briefly introduction of Ryzen. Ryzen was founded in Yinghai in China at 1986, and we started the PV module business from the 2002, and at the 2010 our company was success in IPO in the Shenzhen stock market, and so from this year there is a very rapid approach and developed for our company. And at 2016, Ryzen was ranked as a top 10 global PV module manufacturer, and also joined the tier 1 company group of the PV industry. At 2017, and the Ryzen Energy, our company reached the 10 billion revenue at this year, and then we also established a National Enterprise Technology Center and also a very big laboratory of the CNS laboratory, and also the witness laboratory with the third-party institute. And 2019, there are two major issues of Ryzen. Firstly is that at this year, we start to develop and research the heterojunction technology and establish a line to produce heterojunction cells and modules. And the second issue and the main issue is that Ryzen is the first company to announce and release the first modules in the world with the 210 wafers and cells, and which the module output is 500 watts, is much higher than 2019, which the major power at that year is about 450. But this year the 210 modules is 500 watts and is the top modules in 2019, and 2020 we have already established and expand our production line as the 210 modules, and so far the maximum module output is more than 600 watts. And also in the last year, I mean the 2020, our heterojunction module also have ranked the #1 annual shipments in the last year. It's more than 70 megawatts. So this is just some brief introduction. So for Ryzen, we have the several main business. The firstly is that we produce the silicon, we produce cell, module, and some other non-silicon material like EVA, aluminum, ribbon, and G-box. And another main business of Ryzen is the PV power project like EPC, and some project investment and development. And also we have a subsidiary company who produce the energy storage system. We can provide a solution to the customer regarding all the energy management system. And we also established a profile quality management system from the raw material inspection supplier control to the final customer service. And we also just, as what I just talked, we have a very big and perfect laboratory, CNS laboratory, and we can do all the IEC 61225 and IEC 61730 tests in the laboratory, and all our new product and produced product are tested in the laboratory. So, above is a briefly introduction of our company. So my main topic today is talking about Titan modules. So firstly, I want to see that whether it is to improve the cell efficiency or to improve the module power or to strengthen the module reliability, the final purpose is to lower the LCOE. So no matter in Ryzen, when we produce or we make some research of our module product, the final criteria and the only one criteria is to check if this new product can get LCOE or not. And this year, I think everybody in the PV industry, I feel very, how to say, but I can say it's amazing time, and I can also say this is a very exciting time because there are very huge changes in this field. Just a few years. I remember it's from the 2019 and to now is maybe only 2 to 3 years. All the cells was changed very fast from the M2 to the G12. So together with the cell change, we can see that the module power was increased very much, but we can also very happy to see that the LCOE has already decreased by this way, and we can also see the large cell helps to achieve the lower LCOE, and it is also a better way and a faster way to achieve it. So here are 2 drawings that I collected from the search consultant company, and here just show all of you the cell capacity trend and the module capacity trend by size. So from here we can see that in the future almost all the modules will be produced with the higher with a large cell, and especially for the Chint cells, and we can see it takes the most proportion in the future, and we think it could be the future trend. And according to the information I get from the current industry, almost all the manufacturers in China, when they produce their module line, maybe they also announced to produce some smaller size cells, but they also equipped their production line which can produce the 210. So I think everybody will be very clearly that the 210 modules and the 210 cells will be the future trend of the market. So then how about benefits to the value chain by the 210 cells and the 210 modules? So I can give you some brief introduction. Firstly, let's talking about the silicon rod. So if we compared, okay, we just compare with 182 cells, 182 silicon rod. The 210 will increase the production rate of the monocrystalline silicon per unit time. So after the calculation, we can see that the yield increased by more than 15%. So it will decrease the cost of from the silicon side. And another is the silicon wafer. So we just only to see this one point that compare with the 10-inch wafers, the 12-inch will also increase the production yield, just like on the area. So each slice will be by more than 5%. So it will also be a way to decrease the cost of the wafer. Thirdly, talking about the solar cell. Compare with the 182, if we invest for the whole production line, for the cell line, the investment amount per gigawatt of the cell production line will be 20% lower than the 182 investment. And here does show you the PV module. So the left drawing does show you some drawing of the modules. with the smaller cell and the big cell. And the right side to see that the weight space. The weight space means the space between the cell and between the strings. We can easily to find that if the module cells was if the cells was larger, and the wasted space will also be decreased. So this is also a way to increase the space utilization, and we can also simplify the whole process. And another one is we can see the non-silicon cost, because if we use a big cell, and of course the module area and the module parameter will also be increased, but they are not in a special ratio. So it means that if we use the big cell, the parameter was increased, the area was increased, but the area just will be increased much because increased much. It means that even we have some material cost increase, but actually if we divide by the power, the cost per power will also be decreased. So this will be very easy to be calculated. And here I just calculated the frame. So if we compared these two modules, the frame cost will be reduced about 8.4% compared between the 210 and 182. So another one is that I think I'm not sure if all of you to know this information, but in China here, in the 27th November last year, there is an announcement by the 8 companies in China who produced 210 modules, and also some inverter company and EPC company. So we have announcement about to standardize the 210 series product. It means that in this announcement, we just to standardize all the module size, module length, module width, and all the mounting position, and all the cell design, including the busbar distance, the busbar number. So everything just to standardize them together. And I think it will be much better for the, I also write here, so it will be benefit to the whole supply chain and the whole PV, whole supply chain, the whole value chain. For example, for the material supplement, the cell supplier don't need to change the screen every time for the different customer. They can just to produce one type of cell will be sufficient. For the frame supplier, they can also to supply the same frame to all his customers. They don't need to change again and again. And also for the manufacturer, if we have the same type of the material and the same size of the material, we can use them together. We don't need to request the supplier to change their production line time by time. So it will be much benefit to the whole supply chain. But if we check before other products from the M2 cell module and to the M10 module, you can see the drawing in the slide that we can see that no matter the length and the width, every manufacturer's products are different. I think it will not benefit. It will take some problem for the, for example, for the final PV installer or the EPC company. If they cannot to exchange the module very frequently, if they want to change the module from another company, they have to redesign the whole system. I think it's not so good for the PV system design and installation, and also the future for the PV system maintenance. It's also a problem of that. And here is the PV system. So we just calculated, compare with the both and LCOE with 182. But here is just a final result. And on the next page, I will give you some detailed simulation, PV system simulation, compare with the 210 modules and 182 modules. So firstly, we can compare with this module. So 550 and to the 182 modules, which are 540 watts. So here is let's talking about the PV simulation under the fixed bracket. So here we just to make some condition like the minimum temperature at -10 degree. And at here, this page, we just show you that because of the lower VOC of the two-10 modules, and we can increase the serial numbers by 30%, and also increase the series power by 32%, because the module power is higher than the 182, and also the lower VOC, we can connect more modules per string. So this is the reason why we can to get the highest string power by this product. And here is just a simulation of the final the simulation of the whole system. So before this, we just to calculate and make the system design, and we just to ensure that the whole year there's no shadow on the module from the 9 a.m. to the 3 p.m. So we just to make the calculation, and here is the area comparison with the 210 module and the 182 modules, and we can see that even the module length is bigger, but actually the whole area of the 210 modules, 550 watts, the whole area of this power plant, about 10 megawatts, is still less than the area of another product. Our calculation result is about the 10.5% decrease. And here is some calculation regarding the steel rail used for this system with a fixed bracket, about a 4% decrease. And here is the pile foundation of this fixed bracket system, about the 3% decrease. And here is the tracking bracket. We just use a 1P. So here we just calculate here because you know a moment ago I also see some audience is checking this. Yes, of course, if we install more modules here in one string, the length will be also longer. But actually, we can it's no need to just check. How to say? The axis was enlarged and enlarged. We need to calculate the final LCOE and the final cost, final both cost. So this is the final result we concerned and cared. So here is for the tracking bracket, 1P tracking bracket, we can see the Titan will can increase the power capacity of each tracker by 20.7%. This is also a way, it means that even we use the tracking bracket, we also get the highest string power for this kind of system design. And how about 600 watts modules? So I think the calculation result is very similar. It's also due to the lower VOC at -10 degree, and compared with the 72 cells modules, this module can also get the highest power string power. And we also have the same design logic, and to make sure that in the whole year there's no shadow from 9 a.m. to the 3 p.m. And we make the design of the whole system, and we can find that the whole area of 210 modules also decreased about the 7.3%, and also the power foundation was reduced. And also if we use the tracking bracket for the 1P tracking bracket for the 600 watt modules, and it can also the highest string power on one axis. So here is the final result. So we just compare with the 166 modules, 182 modules. And here are the and also the fixed out, the 1P tracker and 2P tracker. So if we compare with the both and the LCOE, we can find that the large cell can have the significantly improve improve the performance of the whole system and very significantly to decrease the BOS and LCOE. But actually, the BOS and LCOE are very related with the different system design. So it means that the results will be various with the different system design. Both 182 modules and the 210 modules can also reduce the BOS and the COE compared with the modules of smaller size. But actually, under the best conditions, the 210 series products are still the one that can reduce the BOS and LCOE most. So this is the final result of this kind of product. So here is the Taiyang family of Ryzen. So far we have the 4 products of our Taiyang modules. First one is the Taiyang S. So this is 400 watt modules with a 210 cells, and these modules will be mainly used in the distributed market and the rooftop market. And another 3 modules type in the 550, 600, and 660 watts. So these products will be used mainly for the utility scale project, and all these modules are equipped with the monofacial and the bifacial product. And all the modules, and we are using a lot of advanced technologies, such as the half-cut encapsulation, and in the half-cut cell, and we use the non-destructive slice technology to ensure there's no additional stress on the cell, the cutting cell surface, to ensure the micro crack performance of the whole cell and the whole process. And we also use the low degradation cell, and the first year degradation is no more than 2%, and the annual degradation for the bifacial module will be no more than 0.45%. And we also use the high density encapsulation to increase the module efficiency, and this is also the main process in the Ryzen module line. And also this is a kind of the multi-bus bar technology we also use. So all the modules, all the cells, 210 cells we use is the 12 bus bar. But actually, in other companies who also produce the 210 modules, they also use the 12 bus bar. We have the same as what I just mentioned, that we have already have the product standardization. So all the cells we use are with the same design, same type. And at the beginning, when Ryzen to introduce this product to the market, there are lots of questions. So I just to select some questions and give answers in this presentation. Firstly, some customer or maybe some colleagues will ask that how about container loading, because they consider the module is too wide and you cannot make the container loading. But actually, there are a lot of ways to make the design to make the better container loading. For the 600 watt modules, we can load about 527 pieces per 40 feet containers. And for the 550 watt modules, and for the monofacial, there are 620 pieces per container. And for the bifacial modules, two glass modules, we can load 700 pieces per container. So there's a detailed drawing here. And also some customer and some friends are very interested in the inverter compatible inverter. So for the inverter, I think there are 2 different types. Firstly, it's a centralized inverter. And here I just make the single inverter, this type as an example. For the centralized inverter, it'd be much easier because it's a kind of inverter that compatible with the 210 modules. We just need to replace the fuse in the combiner box of the system. So then this kind of inverter, centralized inverter can be used. For other centralized inverter, they are the same. You just change the fuse and then we can use. And another one is the string inverter. String inverter, I think, mostly used in the PV industry more and more. And here I also just to list two brands here. Firstly is Huawei. So here I also just list two type of this of Huawei. And this product now is already compatible with the 210 modules with the big current. So you can also check the type in their website. And another one is Xenon. Xenon is also developed a new product at the SP250K-H. So this product is perfectly compatible with the 210 modules, and we can get a very high capacity ratio by this type. And as the colleagues from Trina just said, that these products will be available at Q1 this year. So if you are interested, you can check their website to get the detailed data of this kind of inverter. And here is the power roadmap of our Titan series. And last year, we have already reached the 450 watts. And the future, together with the cell efficiency increase and the different cell technologies, we hope that at 2022, we can get module power as the more than 700 and reach to the 720. And here is the planned capacity of cell and modules of Horizon. So far, we have the 20 gigawatt cell capacity, and 15 of them are equipped and designed as 210 cells. And for the module, we planned for the 28 gigawatts. And more than about 70% of this module capacity are defined and designed as the 210 modules. So we also hope that we can meet you in our company and in future and talk about more detail about this product. So Michael, so the above is my my presentation, and thank you, Michael.
I'm here, Danny. Thanks listening. Very great. I think that was wonderful. A few questions we should have. So I think what I found pretty interesting was the standardization group you mentioned. Can you maybe elaborate a little bit more on this? So how does that work, the standardization group? Is it possible for who's it open, or who could join that, even if companies from abroad would be interested? So can you just explain a little bit how the standardization group?
Yes, yeah, of course. You know, I think I joined. Okay, let's talk about it briefly. As you know, that in the past 2 years, I mean, from 2019 to 2020, only 2 years, the cell size was changed very, very fast. From the M2 to G1, from G1 to M6, and from M6 to another one. But for the manufacturer like Ryzen, we think this market come to be too crazy. Because if we already invest a production line, and I think this production line can be used for maybe 5 years or 10 years, but actually, together with the cell change too fast, maybe only 2 years, we cannot use the line because the cell size turns big and we cannot produce the cell here. So it's a very big waste for Ryzen, I think also for the whole industry. So at this time, I think at 2019, I think Zhonghuan and this company to introduce the 210 wafer to the market, and we are very interested at that time. So we think this could be the final and terminator of the cell size. So we think and then we decided to produce modules with this kind of design, 210 module, because so far it is it is the biggest one in the market, and for the standardization of the 8 company, this is also the one reason that we just want to fix this wafer size, fix the module size. The detail of this this announcement is that between the size of 210 to 220, this wafer size range, and everybody will take the 210 plus minus 0.5 at the standard cell size, at wafer size and the standard size, and to ensure that the whole industry can follow this. Actually, at the beginning, Trina, Ryzen, Trina, and other several companies, we sit together and make this decision, and we announce it. And every top management in the company sign this announcement, just to avoid that other guys come to here and say, okay, guys, you produce the 210, I produce 212. Okay, you produce the 212, I produce 215. So it makes no sense for the whole market. It's just a waste. So I think this is the reason we do that, and how we do that. We just combine them together and tell them, okay, if we produce this and we need to unify all the standard of this, it will benefit the whole industry chain, not only 1 or 2 companies.
Okay, but this group is still open, so whoever wants to join can join. And how does it work?
Yes, of course. Because you know, at the beginning there are also open a line for the 600 watts, and this alliance not only the module manufacturer, but also the inverter company, the tracker company, and also the wafer company, cell companies. They all join this alliance of the 600 watts. But this alliance is not a closed alliance; it's open alliance. If you want to join, and you can join. There's no any limitation for that.
And who would be the contact to get in touch with?
Oh, this I'm not so clear about that, but you know, the Mr. Zhuang, our marketing director, I think he will
okay,
we can about that. We can check with Mr. Zhuang, Liu Zhuang.
Okay, good. Okay, then let's talk on the panel. Maybe quickly, I think. What else did we? I think there were questions, obviously, about the 720 watt module you mentioned. Will the dimensions be the same? So will it be just that you move from PERC to HJT, or what will change there?
You mean it's a future technical roadmap for Ryzen?
Yeah. So how will you get to the higher output for the future modules? Will it be just an efficiency increase of the cells, or will there be also?
No, we will not increase the cells. It looks not so a good way, because no endless to change the cell size, but in future.
No, only the efficiency. So it means you go to H if higher efficiency.
Yes, from P type to N type, the K2 junction.
Okay, I think that's it. Then let's discuss the rest then on the panel. Thanks so much, Danny. Great presentation.
Thank you very much. Thank you for.
Have a nice evening.
Yeah, you too.